So I'm going to show an example of a trial and error solution for a vertical curve problem where we're trying to pass a curve through a fixed point. So we're basically solving for the length of the curve. And I'm going to focus on this trial and error solution, which can be useful if you, in particular, have a multiple choice exam where you are given the possible answer choices. You can do other ways of just trial and error random numbers, but it helps if you have a small subset of values. So we're asked to find the length of a vertical curve that will pass through point C. Point C has a station of 8 plus 95, an elevation of 1,453. So that's the fixed point we're trying to meet. We're told that the length is either 400 feet, 500, 600, or 700 feet. We have a G1 of -3, a G2 of +2, and we have a PVI at station 8 plus 40 that also has an elevation of 1,450 feet. It would make it easier if we were given information about the PVC, and some problems will give you PVC information, and that kind of fixes one of the unknowns. But in this case, we don't have it, so we don't know several things about this problem. So we're going to have to frame everything in terms of this length and solve for this equation. So like most vertical curve problems, we need our parabolic equation, y equals ax squared plus bx plus c. Plugging in our values that we know for the terms a, b, and c. So for the term a is g2 minus g1 divided by 2 times L. B is g1, and c is the elevation of our PVC. And in this case, we don't know exactly where our PVC is because we're solving for the length. So we're going to put it in generic terms. It's the elevation of the PVI minus G1 times L over 2. Plugging in our known values, so we know our fixed point, that point C has an elevation of 1,453, so that's our known elevation, and we're going to plug in for the rest of this our G1 and G2, and we know the elevation of our PVI, and so we're just going to now start simplifying this equation. So we can, there's multiple ways you could simplify it. Taking it just maybe one more step, one layer of simplification, we can bring it to this point. We've now got one equation and two unknowns. We've got both x and L as unknowns, so we cannot solve this with the given information. We need two equations. If we have two unknowns, we only have one equation. But if we think about this, we can frame x in terms of L. We are given we're given the stations for our point of interest, point C, and we know that that occurs 55 feet or 0.55 stations past the PVI. So x is just L over 2, so half the length of the curve. That's the distance from the PVC to the PVI. And then we know from the PVI to the point of interest is 0.55 stations. So we do know x in terms of L. So now we can plug our value of x into this equation. Now we're only going to have one equation and one unknown. So we can solve this. We can solve for L. Before we walk through these last points, we should also think about what we're going to expect with this curve and with the values we get and with the length. We only have 4 choices. So we can also use just one solution to help us refine what we may try in the second one. So if we've got this point C, we want it to hit at elevation 1,453. If we solve for our equation and find that our point is higher than that 1,453, we know we're going to need a shorter curve to move that point lower. And vice versa, if the point that we solve for is below 1,453, below where we want point C to be, we know we're going to need a longer curve to raise that point up on that vertical curve. So here's our equation again. And this is one of those things that everybody may work this different. You can certainly simplify this more. So depending on your calculator or your interest in trying to simplify this, this may be a good place to plug in values for L. You're trying these various 4 values, or you can again simplify it and solve things. You could fully solve for L at this point if you want to, and just come up with that more precise solution. But in an exam type situation, you may want to stop here and just plug in those 4 values that we were given. So plugging in an L of 4, everything needs to be in stations. So that 400 feet is 4 stations. And we're going to keep our left side the same, 1453, plugging in 4 for L everywhere on the right side. We're going to get a value of 1452.41. Those obviously are not equal, so 4 can be crossed out. Now, again, think about what we talked about with whether you need a longer or shorter curve. If you were doing this more manually, you may want to pick one of the middle values and then move up or down based on whether you need a shorter or longer curve. Plugging in L of 5. This is our answer. This is what we think it's going to be, is our second one. 1453 is equal to 1453.001. That's probably it. There's maybe some rounding that's going on here. We expect this is going to be it, but I'm going to finish out our other values. So the length for 600 feet, or L of 6 stations, 1453 does not equal 1453.601. And similarly, for an L of 7 stations, 1453 does not equal 1454.208. So our answer is a length of 5 stations is the length of a vertical curve that's needed to fit through point C and that elevation of 1453 at point C. There is a more detailed and precise solution that actually builds in various components of the grades and lengths and this term S that allows you to solve for the length. This is not given in the current reference handbook for the NCEES PE exam. So I've solved this in another video, and I'll put the link in the description. So if you want to see this worked out, you can see it there. But you're not going to have this equation in the reference handbook. So you need to figure out another solution, which I'm recommending this trial and error solution, or just fully solving for that L that we worked through. So putting everything in terms of X and L, and then eventually putting X in terms of L as well.